Uh, and yes, of course, good afternoon, everyone. As a coordinator of IEEE Student Council of ZA University, Mathura, it gives me immense pleasure to welcome you all to this special two-day online workshop on machine learning with Zen AI. We are truly honored to have with us Mr. Gauranga Baishya from Harvard University as our distinguished guest speaker. And of course, your presence here is an inspiration for our students and as a faculty as well. And we are grateful for the opportunity to learn from your expertise in the field of machine learning and Gen AI. As you all know, this workshop has been designed to empower our students with both fundamental knowledge and hands-on insight into the fast evolving world of AI. So I'm very much confident and with your guidance, the participant will gain some valuable skills, explore new research directions, and will be motivated to create impactful project that bridge the theory with real world applications. Once again, I extend my warmest welcome to you, Mr. Vishya, and to all the participants joining us today. And now I would like to request Professor Ashish Sharma sir to address the gathering. As we know, SAR is one of the most supported and one of the very integral part of IEEE Student Council. And in short, we can say SAR is the person behind the success of IEEE Student Council. So I request Dr. Ashish Sharma sir to address the gathering as well as our guest of honor. Please, sir. Over to you, sir. Please unmute, sir. Priyanshu. Shelja, please unmute, sir. Priyanshu, are you? Can you hear me?
Yes, ma'am, just a
Then
second.
Yes,
Okay,
yes,
okay.
yes. Unmute,
Thank
sir.
you. It's unmute now. So first of all, it's a good afternoon to all, and very warm welcome to our expert Gaurang Kumar Baishya. And really, I am very much excited to meet you personally because as per your this website, particular website, as per your profile, I am very much excited to know that how you have made this journey from BITS Pilani to Harvard, and really, this is again a very remarkable things, and you are doing a wonderful job over there. So, and definitely this particular thing will motivate even also I am also motivated from your profile, as well as the student will also get benefit from your knowledge, your expertise, as well as they will also I request you to show you the complete path that how one can reach from a simple institution to the BITS Pilani, then after that Harvard. So in this particular direction, if our student will move further, then definitely they go for a particular research lab for a particular research related aspects, either in India or abroad as well, and what kind of the different applications that can be developed with the help of Gen I. So really, even I am excited to join a complete session, but due to certain time limits, and I am engaged in my conference. Uh, I would not attend a whole session, but yes, whenever I will feel free, then definitely this meeting will be always in the online mode on my system as well. And my best wishes to you, Gaurang sir, and all the participants, as well as all the team members who are organizing this event. And I would also request Munmi madam to continue this particular event. We should have, I think, a series of lectures from Gaurang sir. This is my request to Gaurang sir as well, that you should also provide us more time after completion of this 2 days workshop. So that we can get a great benefit that what particular cycle will be there, and how the student and we even the faculty members can improve in this particular technology. This is a very new or latest one, that is a Gen AI. So really, I am excited to join, but due to certain limits, I will not be able to join a complete session, but yes, my best wishes to you and all the members. So please continue the session and most welcome, Gaurang sir, please. Thank you.
Thank you so much. Hi everyone. I hope you all can hear me, right? I'm audible? Am I? Okay,
Yes, sir. Yes, sir, you're audible.
okay, great. Thank you so much for having me here. I mean, it's really a pleasure to be able to address my friends and juniors. And yeah, I mean, not only you all will learn something, I guess I will learn a lot of things from you all as well. So I just want to, you know, one second, what is this? Confirm your speaking language. Okay. Yeah, sorry. There was just a pop-up out there. And yeah, I mean, it's really great to be here. Thank you for having me here. I mean, I would love to continue the session in the future. And yeah, I mean, we can definitely have some more sessions in the future as a continuation of this workshop. And so let me get started. So I can get started from here, or is there
So we can get started with the workshop.
okay, sure. Great. Yeah, so I'll just put a brief agenda behind what we're going to do. And before I speak anything, I just want to make sure that please feel free to ask me anything. There would be certain occasions where I would not be able to answer questions. Sometimes I might not know the answer. If I know the answer, definitely I would love to have a discussion on that. But please feel free to ask me questions. Please feel free to stop me anywhere and ask me anything you want. That's the first thing. Secondly, let's go ahead with the agenda today. So I will have 4 hours with me. And now I will be giving you all 2 hours. And maybe the next session is from, I don't know, 3 to 5. Is that the timing? I forgot. It's 1 to 1,
It's 5 to 7. Next session, 5 to 7.
5 to 7. Okay, next session is 5 to 7. That's fine. So, right. So the first 2 hours, that is now, I'm gonna talk about the very basics of machine learning. So I was made aware with the fact that most of you, this entire workshop is arranged for first year and second year students, and there are a couple of other people as well who are in the third year, some research scholars and stuff. Uh, but yeah, I think it's mostly for the first year and second year students. And I was made aware that they do not have a core ML courses that they have taken in their curriculum. Although there is AI track, something I'm not particularly sure. So before we go on to the main, the not if not the main, something which is very much prevalent nowadays, which we call it Gen AI. It's going to be very difficult for me to go directly and jump into Gen AI. And before we do that kind of stuff, I think we need to go ahead first learning the very basics of machine learning. So this is what the entire 2 hours right now would be learning the very basics of machine learning. It's not even the basics of machine learning. It's like the basics of machine learning kind of stuff. Depending on how you categorize this learning journey. Okay, so this is something we will see first. The first 2 hours, I'm gonna be a bit boring. Don't mind with that. I'm gonna present a few slides. I'm gonna have a discussion with you all. Feel free to unmute yourself and ask me anything again. And we'll see a few things about machine learning first, the very basics of ML. And then from 5 to 7, the session from 5 to 7, what I will most probably do is either continue with the slides if there is time, if we couldn't finish now, or if I have finished the slides, the two sets of slides that I'm going to present now, if I have finished that, then I will most probably go ahead and do some hands-on with coding and stuff in Python. Okay, this is the second thing. The third thing that I would like to say is, while I present something, there might be occasions. Okay, before this, let me share my screen because the screen is very blank. Right. Okay. Okay, what do you see? Can anyone just confirm? Do you see my slides? In the first page of the slide. Priyanshu, anyone?
Yes, sir, it's
Yes,
visible.
sir.
Okay, great. Uh, all right. What I was saying is the third thing. The third thing is that whenever I will present something, it is very normal to see something on the screen which is very difficult to understand. Okay, this is something we all have faced, even even during classes, or if we have attended some conferences. It is very common to face something like this. We see something, the person presents something, and there are certain lines, mathematical derivations, or concepts which is very difficult to understand. Again, first of all, unmute yourself and ask me if there is anything. I would love to discuss. Second, don't get scared. Okay, this is something I would like to say. Don't get scared by saying something which you have seen for the first time. Because I do not have much time, I only have 8 hours, although 8 hours is a very long time. But to be able to understand the entire field of machine learning, to be able to understand the deep learning revolution, to be able to understand what this entire thing is going on in this world, what is Gemini, what is how did everything come up to be? 8 hours is not enough. In fact, a lifetime is not. It's a beautiful thing. It's a very, very interesting thing, and there is a lot of intricate math. When I say math, I mean a couple of stuff, uh, mostly stats, probability stats, calculus, all these things. Um, Complex math, a lot of complex math, a lot of understanding. Some philosophical things come into the picture as well. So there's a lot of things that's going on under the hood. And a lifetime is not enough to learn all of this. There's a lot of things going on in this world. So 8 hours is definitely not enough. So don't get intimidated by saying something which looks very difficult. Feel free to ask me. I'll try to answer the best way I can. And even if I cannot answer, uh, then you should definitely go ahead and look at it. Go back, maybe surf the internet and see, learn by yourself. I'll give you my contact details. You can reach out to me. We can have some more conversations later on. But yeah, these are the things that I would like to state because we have a long sessions coming up ahead. Okay, without making any sort of delay, let's get started. So are you all guys ready? Uh, okay. Great. Thanks. It's really lovely to see you all say yes. Uh, yeah, again, feel free to unmute yourself and ask me. Write in the inbox someone who is taking care of all this. I forgot his or her name. They will just most probably unmute you and let you speak or something. I'll try to answer them. So, okay. Okay, let's get started. So this first session, after this session, I'll give a brief break. Again, I am very fond of giving break. I can understand that uh, lectures can become very boring, and today is a weekend. Unfortunately, you all are having a hard time here joining me when you could have been sleeping in the in your rooms. But yeah, thank you for joining, even on a weekend. So yeah, let's get started. So I'll be covering the very basics. I'll give a short presentation, then we will take a break. During the break, we can have some informal conversations and stuff, or maybe you can take a 5-minute nap or something. Okay, fine. Okay, right. So the slides is all about the machine learning landscape. So I would like to give a very, very brief description of uh, the key points, the most important points in machine learning. Okay, something we need to keep in our mind, even if we have a lot of things going. My first question is, so I'll be making this session very interactive. So I'll be having a look at the chat box as well, because I don't think you have the privilege to unmute yourself and ask. My first question to you all is, uh, what is machine learning? So this is something I would like to ask. So people can just write down on the chat. I will have a look at it. And if anyone wants to speak, please feel free to unmute, help that particular person unmute. And yeah, we can have a discussion. That's the first question. What is machine learning? Have you ever heard of machine learning before? Have you heard of this word machine learning before? What do you think it is? If you have not heard of machine learning, teaching machine how to solve some problem. That's what Vedant Jain says. Any more answers? Enabling machine to think or respond like human. Beautiful answers. Training a model with input and output. Okay. Yes, sir, but no idea. That's fine. That's completely fine. Machine learning learns from past data to make future predictions or decisions. All right. Okay. So how do you know that all the data is past? I mean, why past data? That's fine. I'm just asking a question. Making machine learn or train to predict something. Avani Garg says that. That's fine. Okay. Teaching a machine how to evaluate and process data and predict some outcomes. Okay. Wow. We are getting a lot of answers. It's getting difficult for me to follow. It's a technique where we build a machine which is the real world problem and solve them. Great. We have beautiful answers. Thank you. Thank you so much for giving all these answers. I mean, most of these answers are correct. Uh, I mean, all of the answers are correct. This is all I know as well. I mean, I think I know as much as how much you all know. But let's see what experts have to say on what is a machine learning. That's what my slide is all about. So let's go to the next slide and see what is machine learning. Okay, so it says that the core idea is pretty simple in machine learning. It says machine learning is the science and the art of programming computers so they can learn from them. Great. I think most of you have said this. Learning patterns or data analysis. Fine, great. This is the core idea, but let's see what machine learning actually means in more, you know, among the scientific community. So I'll just most probably decrease my size of the screen. Okay. 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 This is the first back in 1959. This computer scientist Arthur Samuel, he said that the field of study that gives computers the ability to learn without being explicitly programmed. That's machine learning. That's what he said in 1959. Okay. So you want the computer to learn without being explicitly programmed. So when I say explicitly programmed, you do not want the computer to, make some decisions based on some rules. You want the program to learn all by itself. That's what machine learning means. So I said explicitly learn. The next line of some so-called definition, which is not, it's not a definition per se, but something some great people have said. So Tom Mitchell is a big person, is a big shot. Uh, if you have not heard of him, maybe you can have a look at the book written by Tom Mitchell on machine learning. So he said in 97, he gave a more of a theoretical definition of machine learning. He said that a computer program is said to learn from experience E with respect to some task T and some performance measure P if its performance on T as measured by P improves with experience. That means you have a experience. It's kind of some sort of a personalized manner. I mean, this is how, so-called a human being does this, right? Uh, you do some task, you get some performance, and you get your experience updated. Okay, so this is what it means. A computer program is said to learn from experience E. You're learning something from your experience, and the learning is with respect to some task T, all right? And the performance measure. So there is a performance measure. It's some sort of a reward, you can say. Okay. Say, for example, you're learning to bicycle. Okay. To not fall off the bicycle is your reward. Okay. So that could be some sort of a measure, a performance measure. Okay. With some performance measure, the performance improves with on the task with time and with experience. Okay. If that is something that's happening, then we say that the machine is learned. That's what Tom Mitchell said. But these, I mean, I do not the exact definition of machine. I don't think that even exists. But yeah, more or less the word machine learning means this, whatever you've seen. All of them are very, very correlated. Okay, so let's see. For example, when you open your Gmail, there are two different folders, right? The folder where you have your inputs, your emails, your active emails, and below the folders, you have a small folder that's called spam. So how do you think you do not put your emails to spam, right? The spam emails are put there by itself. So that means the program is doing that. The entire Gmail application is putting your spam emails there. Okay. So how does the Gmail learn which email to put there as spam and not not put there as not spam? That means put the non-spam emails in your inbox. Does it not make any mistakes? It does make mistakes because sometimes if you have heard people say, hey, if you haven't received my email, maybe you can look at the spam folder. You can find my email there. You could find my email. So how does the machine do that? So your task is following. So when I say based on this definition, your you need to flag an email as spam or not spam. That spam, that is your task. What is your experience? Experience is you have some training sample, and the training sample consists of some spam and non-spam emails. Okay, that's going to be your experience. So this is your experience. You're learning on your experience. So you're building your experience on this training sample, the data of some examples of spam and non-spam emails. Okay. Now, do not ask me how do you get this data. I mean, you do not get this. The machine, it's a bit of a it's a bit complicated to explain that, but you have just imagine for the sake of this that you have some training data and you're building it on that experience. So this is your experience. And what is your performance? A performance is your satisfaction. Okay. The accuracy of spam detection. So if you have a high accuracy, you're satisfied with Google Gmail, you keep using Google Gmail. If the accuracy is not good, then you are not satisfied with Google Gmail, and most probably you change to Yahoo Mails or Microsoft Outlook, whatever, any sort of other mailing platforms. Okay. You lose customers, you do not lose customers. That could be your performance metric. So Google keeps track of how many people use this and how many people do not use that. And that could be in your performance metric. So the entire Gmail application is some sort of a machine being learned whether to put an email to spam or not spam. Okay, so that could be your machine learning. Great. So far so good, and I'm really great. I mean, you all have got me correct. Even if you all did not have courses in ML, you are aware of what's ML. Okay, but the next question, the most so you guys can see my slides flowing, right? I just want to make sure that that's happening. Can anyone confirm? Shailja?
Yes, sir. It's visible. Your slides are visible.
Okay, so you can see this two diagrams out there, the traditional ML approach right now.
Yes, sir. It's there.
Okay, great. Okay, so the next question is why machine learning? That's my next question. So can you guys thank you for thanks everyone for the confirmation. Yeah, you all are sweet people, great people. Thank you for being so, yeah. Okay, so the next question that I have, 1 second, I lost my slide. I mean, I did not lose the slide, but I lost my screen. In the meantime, why don't you all just wait a minute. All right. 1 second. Okay, right. Sorry. Okay, got it. Sorry, I just lost my slide for some reason. Okay, you want me to zoom in? Sure. Yeah, sorry. This is your zoomed in version. Okay, so my next question to you all is why use machine learning? Why not why not do some sort of non-machine learning? So if there is machine learning, there is a non so-called uh to do something without machine. Why do machine learning at all? That's my question. To automate our tasks. Okay, that's a good answer. What else? Any more answers? For automation, pattern recognition, and implementation of recommendation systems. Okay, that's something. To fasten up the tedious task which a machine can easily do. I mean, okay, fraud detection and data study. Okay, these are some very cool uh, use cases of machine learning. So can you with the help, can you also let me know why would a non-machine learning fail here? To increase accuracy? Okay. To make human work more easy, and automate possible tasks which can be headache if we repeat again and again. Okay. To work a lots of data. It only depends on what we code. Okay, enable computers to learn from data. And okay, great. Okay, thank you, Yashika, Anush, Vedant, Rudraksh, everyone who is answering. Thank you. It's not possible to look at all the answers, but that's fine. Thank you for all the answers. I mean, most of you all are correct. So this diagram defines the main advantage of machine learning. So what's a traditional approach? Traditional approach could be, for example, write rules, right? Say, let's use the traditional approach to define the Gmail area, the Gmail thing I discussed about. Okay, so what could be a traditional approach? How do you categorize whether email is spam or not spam without machine learning? Yeah, it's simple. For example, so you use some rules. There is no learning. There use some rules. And what rules could that be? For example, if you are okay, so if you are a person who is into academics, okay, you wouldn't most likely be interested in some sort of emails that's kind of says, hey, we have an incredible offer on shopping. in this particular platform, and there is a 66% discount, sorry, 90% discount or 50% discount going on for these sales. If you're into, if you are not into shopping, then most probably this email is a spam, right? So one possible rule could be that if you look at the word 50% discount, then most probably that is a spam. Okay, that could be a rule, for example. That need not be a rule, but that could be a rule. So that rule's gonna be different for different people. How many rules are you going to write? Are you going to write like a 1,000 rules for every person? Who's going to write the rules? So that's a big issue, right? You wouldn't want to write so many rules, right? You wouldn't want to write. So the traditional approach could be very hectic. So what happens is, first, in order to evaluate your model, you analyze the errors. To analyze the errors, you study the problem. To study the problem, you write rules. And you do this, and once a particular threshold is reached, you launch the program. That's your traditional approach. And writing rules can be very, very tedious. Okay. So this is what I say. Problems requiring lots of hand tuning or long list of rules. Who's going to write the rules? Okay. Some problems do not have a traditional solution. And okay, this is a very important thing. You might suppose, even if you write all the rules now, who says the rules will not change tomorrow? Or maybe the rules might change tomorrow. That might happen. Are you going to rewrite the rules again tomorrow? You already took like a lifetime to write them all. Who's going to do that? So that's why machine learning is very important. Rules-based systems, they could be accurate if the rules are good, but how do you write so many rules? That's the big question. So that's when machine learning comes into the picture and saves you. Okay. You have this entire thing which looks the same, but uh, instead of writing rules, you have data. You let the machine make the rules from data, so-called. You train your machine learning algorithm to learn from the data and then evaluate your solution. Then you launch the application, for example, the Gmail or any other mailing application. That's when it's useful. Okay. Machine learning takes care of this. Fluctuating environments, you can take care of machine because the machine is going to learn with more data. The machine is going to learn with new data that's coming into the picture. Okay, that's when machine learning helps. Right. Okay. Now that we know what's a machine learning, and we know why machine learning. Let's go ahead and see what are the different types of machine. Yeah, sorry, Vedant, you have a question? Go ahead. Okay, I think someone has a question, right? Or I was mistaken. All right, there is no question. Okay, so let's see what are the different types of machine learning. So the machine learning can be divided on the basis of three categories. The first is human supervision. The next is learning on the fly. And then
Yes,
the third,
sir.
yeah, sorry, go
The
ahead.
Vedant Jain wants to ask you a question.
Yes, go ahead. Please.
Let me
Yeah,
unmute him.
yeah, go ahead.
Hello, good afternoon, sir.
Hey, hi, Vedant.
Hello.
How are you?
Hi.
Are you can you hear
Sir,
me?
I'm fine. Sir, I have a question about what is data mining?
What is data mining? Okay, so
Yes,
data
in the
mining is
last week.
simple. Yeah, data mining is you have lots of data and you want to get you want to extract information from that data. Okay? Because the size of the data is too big. you need to find ways to extract important informations from this large amount of data that we have. That's what we call data mining. There are different ways of there are different ways you can mine your data. That's what uh, to get insights from large amounts of, because the data is very large. You need some ways. When I say ways, it needs to be optimized. Okay. When I say optimized, it needs to make you need to make sure that the program that you're writing doesn't run out of memory. The program you're writing doesn't run out of lifetime, because you only have 85 years or 100 years to live. So you need to optimize your codes. You need to do a lot of stuff. The entire study is called that, right? Did I answer your question?
Okay. Yes, sir. Thank you.
Okay, thank you. Thank you for asking. Yeah, please feel free to ask any questions if you have. Right. So there are these three different kinds of machine learning. The first is human supervision. So when I say these three different kinds of machine learning, this entire study of machine learning has been divided on the basis of these three different ways of doing ML. Okay, so I'll be using the word ML. ML stands for machine learning. All right. So the first way is human supervision. Whether you want the machine, so let's not see all the other slides. That's the region I did not put, so that you do not get distracted. Okay. So uh, when when uh, when there's a human and the human has supervised to give you some training examples, and you want uh, the machine to do the learning from those samples, we call it human supervised kind of machine learning. Okay, so it's simple. Whether the data was trained with human supervision or not, on the basis of that, there are again four different kinds that can be categorized based on human supervision. One is supervised. We'll see each of them one by one after this slide. There is one unsupervised ML. There is semi-supervised. From the name, you can see that it's semi-supervised. Okay. Partly supervised, partly unsupervised. You do not know what's unsupervised and what is supervised. We'll see that. And this is reinforcement learning. And there is a fourth kind called RL, we call reinforcement learning. This is precisely one of the research areas of my domain. And if you have not heard of reinforcement learning, maybe you should go and have a look at RL. It's a very difficult thing. At least many people find studying RL very difficult, but it's one of the most interesting and one of the most amazing ML there is. Okay, if you have heard of cars, self-driving cars, then it's based on some sort of reinforcement learning. If you have heard of machines which has recently beat the most powerful or a human chess expert, then it's RL. It's a very powerful form of learning, and we'll not see much about RL. I would have loved to teach you RL, but it's beyond the scope for today's talk. So the next one is learning on the fly. So when I say learning on the fly, for example, if you have used Netflix, for example, if you have watched Netflix, you would have seen that every week or so there are new web series or new movies coming up, and the Netflix application needs to make sure that you like recommend you sorry a Netflix application should make sure that these new movies be recommended you on the basis of whether you'd like it or not. Okay. So this is what we need to learn incrementally on the fly, because the environment is very dynamic. The environment is changing. The world is not static. Things come, things go. Once there is a movie, the same movie won't be there in Netflix. It's going to be get It's going to get substituted with a new movie. And the recommending system needs to know, for example, whether that movie should be recommended to you or not. So that's what we call learning on the fly. That's what we call it. And the third one is generalization studies. Okay, we'll not talk much about it. Simply says whether they work by simply comparing new data points to known data points, or instead detect patterns in the training data and build a predictive model. One is instance-based learning and the other is model-based learning. So most of the machine learning that we know are model-based learning. There is a model. The model learns on the training data and we test it on test data. And yeah, that's the model-based learning. Instance-based learning is something we'll see next. Okay, I will not talk about. Okay, so let's have a closer look at. Okay, let's have a closer look at supervised learning. So when I say supervised learning, so supervised learning, if you remember, it's based on human supervision. So right now we'll be looking at the the human supervision based ML systems. So supervised learning, right? So supervised learning is pretty simple. You have a training set. Okay. Okay, what's a training set? Did I mention that? I think I haven't. So when you do ML, you need to divide your when you do ML, the model needs to learn, right? The model needs to get itself trained on something. So that set is called a training set. Okay, the training set could be different. Could be different types of training set. Now, if this training set is labeled, for example, like a teacher, if you say, uh, I give you a model and the task of the model is to predict whether the email is spam or not spam, for example. All right. And if I ask you this question, that, hey, I give you this information. So here are the couple of emails which are spam. Here are a couple of emails, say here are 100 emails which are spam. And here are examples of 100 emails which are not spam. And your task is to identify patterns of spam emails, identify patterns of non-spam emails. You update your experience and you use that experience to make a prediction on a new instance. Okay, so that's example of a supervised learning. You have labels. The labels are given to you, okay, on the training set. When I say labels are given to you on the training set, that means I give you 100 emails and I say that, hey, these 50 are spam and these 50 are not spam. The labels are given to you and you learn from those training examples where the labels are given. As simple as that. Okay. Again, supervised learning could be two different kinds. One is classification and the other is regression. So what's the difference? The difference is pretty simple. The spam or not spam, the labels are, so in this spam classification problems, so the spam detection problem, it's a classification problem because you classify whether it's spam or it's not spam. Okay. But sometimes you do not have to, you may not want to classify. Okay. If I give you for example, if I give you a card and you would like to know, for example, how much petrol will be used by the car at the age of, after 3 years. That's not a classification problem. That's called a regression problem. Okay. Because you're not classifying, you're finding a number. What's the expected lifetime of the car? Or for example, what's the expected mileage of the car after 2 years? What's the training set? Training set is all the data you have about the car so far. What do you have? You have information about how many kilometers of the car has the car ran, how much petrol has been used so far, what was the mileage so far, how was the mileage decreasing with time. You have all those information. That's your training set. And you need to predict, for example, the mileage of the car that's going to be after, say, 5 years. Of course, the mileage is going to decrease because it's that's what it happens. That's what happens. So that's a regression problem. All right, great. So this is an example of, again, the labels are given to you. When I say the labels are given to you, the training set, in the training set, you have the information, the labels. Say, for example, you have the mileage of the car after 1 year. You have the mileage of the car after, say, 6 months, after 1.5 years. You have all the past data of your mileage. Okay, your mileage is your, for example, the label. You have that information. Okay, that's regression. All right. Yeah, so these are some common examples of the regression-based machine learning algorithms. We will most probably not go through all of them because it's an entire course in itself. And I do not think I have what we call it. I don't think you all have the mathematical foundations to learn all of them in 8 hours. Because I need to go through the math as well. There is a lot of math going on inside. That's crazy, crazy math going on inside. The math in linear regression could be simple, but for example, the math in neural networks is not very simple. Okay. But yeah, these are some common examples of supervised learning. Great. Before I go to unsupervised learning, I would like to take a pause and ask if there are any questions. Or maybe in the chat box, write to me if you are enjoying it, if you are learning something. Any questions or anything that you will all like to say? Are you guys with me? Is it getting boring? Okay, I can't see any messages. Okay, great. Rohit Singh says no. No, okay, it's not getting boring. Great, great. Thank you. Okay. Great, great. Okay, great. I'm glad you're enjoying the session. Okay, great, great, great. Okay. Thank you. I mean, that's great. You all are enjoying the session. Right. Let's move on. Let's see the next kind of machine learning, which is called unsupervised learning. This is very interesting. Trust me. I love unsupervised learning. It's very interesting. Okay. Based on this picture, can you all guys let me know what's unsupervised learning, machine learning algorithm, or what is unsupervised learning? Anyone? You only have some time to look at this picture. I'm not going to let you see the. Any idea what's unsupervised learning, Amal? Random selection. All right, that's one answer. It groups data. Okay. In left side picture, we target identical people. Okay. What happens to the right hand side? User don't know about input and output. Okay. Machine learning where the algorithm analyzes unlabeled. Shivam Gupta says the computer classifies the data itself based on the certain attributes within the data. Okay, this is something I like. Okay. Prakash says that uses unlabeled data to discover hidden patterns. All right, this is interesting. Unstructured group of data. All right. It's a so Priyash says It's a type of ML where the algorithm learns patterns from data without any labeled outcomes. All right, all right. Divide customers per certain criteria. Okay. User used to identify patterns by analysis of data. Okay, great. We got a lot of answers. I don't think we have any more answers. It uses and label data. All right. Okay, great. Good going. I mean, you all are catching up. Most of you are correct, but unfortunately, the answers are not very good compared to the answers I had for supervised learning. But yeah, we have some answers. That's great. That means you all are learning. Okay, unsupervised learning is as simple as you do not have the labels. You do not have the labels. Say, for example, let me give you an example. This is very, very interesting. Unsupervised learning is a big challenge. Yeah, it's a very interesting form of ML learning. So let me give you an example. Say, for example, you have a couple of say you own a big, if any people are into business, for example, any one of you are into business, say you own a big shopping mall, all right? And it's pretty big. It's like one of the biggest shopping malls out there in the entire state, for example. Okay. Or maybe one of the biggest shopping malls in the entire district or the city, for example, Big Bazaar or something. Then you would have thousands of customers. Yeah, it's not going to be the thousands. But if it's big enough, it's going to be in thousands, probably. So you have a lot of customers. But the constraint is due to some privacy related reasons. For example, you could not or you cannot collect informations about, or maybe for due to some certain results, you do not know much about these people, these customers. They simply come into the shopping mall. You get a little bit idea about the person. Okay, this person is a male. This person is a uh, 26 years old. This person is Indian. This person is that. You know this kind of information. But whatsoever you do not know about the shopping patterns of this particular person, because this person just simply comes to the shopping mall, buys stuff. You get to know about the person's say for example the demographic informations or the identity of the person. That's all you know about this kind of people. But because you do not have access to other informations about the person, you would still want to make a machine. You would still want to make a machine that predicts or that kind of groups these people you have. Okay, these people, these customers. Yeah. Say for example, these four groups of customers are, say, frequent shoppers, for example. They regularly come to our shop and buy, for example, grocery items, for example. Again, these group of people, for example, are a group of people who are not into grocery items, but they, for example, simply come to the shop and buy some random stuff, or maybe buy some vegetables or something. You would like to group these people, but you do not have information whatsoever about the labels of these people. How about doing that? How would you do that? That's unsupervised learning. You see the challenge, right? The supervised is very easy. You have labels, you have a teacher. You have a teacher and you learn from the teacher. Okay, who's your teacher? The person who labels the training set for example. You have a teacher, the teacher you learn from the teacher. But here you do not have a teacher. You have to learn all by yourself. How do you do that? It's more difficult, right? So that's unsupervised. Okay, so these are some examples of unsupervised learning. Let me go one by one. The training data is unlabeled. The system tries to learn without a teacher, finding hidden patterns on its own. I don't know who's the person, but there was someone who did say this. We're trying to find some hidden patterns. Because these patterns are hidden, it's going to be very, very difficult for you to uncover. Okay? That makes unsupervised learning kind of difficult. At the same time, it makes it pretty interesting to work with. Okay, so clustering is one of the examples. What's clustering? You are dividing something into clusters or dividing something into groups. Okay, for example, this is a clustering problem. How do you divide this into these groups? 1, 2, 3, and 4. Okay. So clustering is an example of unsupervised learning. One more example could be anomaly detection. Oh, that's an interesting application. For example, you own a bank, and the bank needs to know whether to hand you a credit card or not, or whether you would be a person who would do fraud with it, would fraud with the credit card. For example, whether you would not be able to pay whether you would be able to pay your funds back once you use a credit card, because that's of concern to the bank. If you are not being able to pay back, then although there are some rules and regulations to handle you, but it's not something you would like to have like that to happen. So you need to find some anomalies, so anomaly detection, or for example, outlier detection. Who's your outliers? In that case, it's unsupervised learning, because uh, the bank doesn't know you. You wouldn't go to the bank and say, "Hey, I'm a fraud." You wouldn't do that, right? But yet you need to discover whether you do a fraud or not. Okay, that's anomaly detection. This is an unsupervised learning problem. The world is filled with unsupervised learning. Okay, this is the most important application of unsupervised learning. Maybe if time permits, I'll go through dimensionality reduction. Um, Dimensionality reduction is simple. It's okay, sorry. It's simple to understand, but not very simple to uh, apply first. The idea is pretty simple. The world we live in has lots of variables, lots and lots of millions and millions of variables or features. So, for example, if I pick a random person among you, among the people out there in the participants, right? Uh, and I would like to define any one of you, then there are millions and millions of variables to define you. The color of your hair, the color of your skin, the way you speak, what language you speak, what's your height, what's your weight. Okay, there's lots of variables. What's your, for example, the blood sugar levels in your blood. There's a lot of things. There are lots and millions of variables. So that's a curse, because if you have so many features, then it becomes very expensive for the model to be trained on. Okay, that becomes a big problem. So that's what we call the curse of dimensionality, or dimensionality reduction becomes a very important issue. You need to reduce the size of your data set per se. You need to reduce the dimension of your data set in order to let your machine learning algorithm work on it. Okay. So how do you reduce the dimension of your data set? That's an unsupervised learning. Because why is it unsupervised? You are reducing the dimension. You do not have so-called labels based on which you will reduce it. Some sort of something like that. So reducing the dimension. You don't have that privilege. And there is some association rule learning. Let's skip this. Yeah, some interesting relations between attributes, like discovering that customers who buy barbecue sauce also tend to buy steak. We also want to say, for example, discover some sort of association between features. That's when this is helpful as well. Okay, right. So we learn what's a supervised learning. We learn what's an unsupervised learning. Let's go back. Let's go and see two other methods, which is semi-supervised learning, and the next method is reinforcement learning. Okay. I will not go deep into this. That's why we have these two informations in one slide. But again, I would do the same thing. I would like you all to guess what's semi-supervised learning and guess what's reinforcement learning, given the fact that I have this slide with you. For example, wait, sorry. Yeah, I'll just zoom in the slide for you all to wait. How do I, right? Yeah, I'll just zoom in here for you all to see properly. And based on this, how about you write to me in the chat what you think is semi-supervised learning and what you think is reinforcement learning. Go on. Read the slides. This is an interesting slide. I think you will all like it. And this one is also an interesting slide. Go on. I'll be there on the chat and see what you all write. Okay. So unlike unsupervised learning, where we both give both input and output for training, here we only provide input data and the algorithm tries to find structure, hidden patterns on the owners. Okay, yeah, sorry. Good. That's great. I missed your chat. All right. He says, how do we handle imbalanced data sets in supervised learning, like spam detection, where most emails aren't spam? Okay, that's interesting. There are different techniques to handle imbalanced data. I think I will talk about this on my next few slides. How to handle imbalanced data sets. And before that, we need to ask the question why imbalanced data is an issue. We need to discuss that thing as well. Okay. Aditya Raj says RL used for training agents to make decisions through interaction with an environment. All right, that's correct. Semi-supervised learning is a machine learning approach that uses both labeled and unlabeled data for training. All right, that's correct. But my next question is, how do you use it? How do you think you will use a semi-supervised learning approach for training? It trains model with small amount of labeled data and large unlabeled data. All right. Can we take 2 minutes biological break? Of course, yes, yes. Thank you for reminding me. Why 2 minutes? I'll give you a 5 minutes break. We take a 5 minutes break. All right, sounds good. Let me know. Shelja, is it fine if we take a 5 minutes break here? Because I think we need to keep our audience active. No worries.
Yes, sir,
Thank
sure.
you. Yeah, yeah, we are welcome, UT, Karma. Thanks for reminding me though. I'm glad you said so. We can take a 5 minutes break. I'll be right back by after drinking a cup of some water. Yeah. Okay, we start at 2:15. All right, so can we start? Let me know the guys. Guys, let me know if we can start, okay? All right. Okay, before we start, here is my LinkedIn account. You all can follow me here. And yeah, that's fine. Okay, great. Thank you. Thanks for being here. Let's go on. Where's my screen? Okay, let's resume. All right. So we were talking about semi-supervised learning and reinforcement learning. So these are some two different types of human supervision. So semi-supervised learning has little human supervision. That means it has training samples which are labeled, but very few of them are labeled. Say you have only 10 emails which are labeled as spam or not spam, and using those 10 labels, you need to decide the other 200 emails out there whether it's spam or that's semi-supervised learning. Okay, so the label data is very less. Reinforcement learning is a pretty interesting thing. It's completely based on how we humans learn from experience. It's very ideal with the, how do I explain? It's very ideal with how you have learned to cycle, for example. How did you cycle? How did you learn to cycle? Okay. It's how did you learn to cycle? It's not a supervised learning method because you don't have some sort of a label here. It's not unsupervised learning as well, because are you trying to find some hidden patterns here? I don't think so. We aren't. It's not unsupervised as well, in my opinion. Rather, reinforcement learning is an entire different paradigm. It's an entire different world of machine learning. So in reinforcement learning, what happens is you interact with the environment. You first put your toes on the paddles, you sit on the pad, and you try to cycle. Okay? You learn to cycle. That's your environment. The environment is the road. You're learning to cycle. Okay. You fall down, you get a reward. The reward is pain. Then you get back up and sit down on the pad. You try to put your foot on the pedals. You try to do that all over again, but perhaps this time a little better. Okay, this time you fall down as well, but not so, not as early as you fell the previous time. All right. So you keep improving with time, with rewards. You fall down, you get pain. Pain is your negative reward. You cycle, you become happy. That's a positive reward. So you learn on the basis of interacting with the environment. You make an action, you interact with the environment gives back you a reward, and you try to, for example, avoid negative rewards in the future, and that's how you learn. How you do that is a different thing. How you learn that, how you learn how to avoid negative rewards, it's what the entire reinforcement learning studies. But for now, if I simply ask you what's reinforcement learning, that's what it is. You learn from the environment, from the rewards given back to you by the environment. That's reinforcement learning. It's a very interesting thing, and it completely follows the human the human way of learning. Okay, so far so good. I don't have much time. Let me quickly go through the other. So I talked about semi-supervised learning. Okay, so if you have used Google Photos use semi-supervised learning to, for example, cluster or label other different photos. Reinforcement learning, you learn with the help of rewards. You perform actions, you get rewards or penalties, which is a negative reward, and you try to improve your action, which we call it a better strategy or a policy, and you try to maximize your reward over time. Okay, when I say maximize your reward over time, that means you try to maximize your positive rewards, for example. Okay, if you have heard of the chess playing engine, what's it called? Alpha, I forgot the name. Alpha something. I forgot the name, but they also have this Alpha Go version, which plays Go. Go is a game. If you have heard of these news, self-driving cars, like cars which doesn't have a driver, it's learning to drive on the road, or a robot learning to walk, a robot learning to walk up the stairs, or maybe Google DeepMind's AlphaGo, which learns to play Go. These are all reinforcement learning based. And right now, this is the most interesting for me personally. It's the most interesting ML thing going on out there. Amazing. It's amazing. Okay, the next is batch learning. Batch learning is, I'll not go much into these. These are some not so popular forms of learning. Online learning is popular if you actually learn about it, but yeah, I mean, let's not dive deep into this. So in a few words, online learning is something I've already said. You would like to learn on the fly. Okay. Right. So to train the system by feeding it data instances sequentially with time. Yeah. Learns new data on the fly. Yeah. Okay. For example, Netflix recommendations. The recommendations, or maybe, I don't know, they're all connected. I don't know if they have this online learning thing, but we can think about it like that. Batch learning is simple, must be trained using all available data at once. And you have a model, you train all the data at once. You have a model and you use that model to learn new data. You cannot learn new data, for example. You cannot update your model based on the new data. All right. Okay, so there is a challenge with online learning. If the data quality is poor, then you won't get a uh, good problem. You need to make sure that the data that is fed to the online learning system is of good quality. Okay. Generalization, instance versus model learning. I'll just probably skip it. So generalization means the goal of ML is to perform well on new instances it has never seen before. That's called generalization. There is this thing called generalization error as well, which is the same generalization as what it says here. I need to make sure that the ML model learns well enough. That means they have a good generalization. That means the model should be able to provide you a strong confidence for a new test case or a new training instance, for example, or a new instance. Okay? New instance. That's the entire goal of ML in general. So there it is, instance-based learning, and there is this model-based learning. So model-based learning is the same that you have seen so far. There is a model, you learn on the basis of that model. That's model-based learning. Instance-based learning, that means it learns by heart. How best to explain this? And I could explain this thing, but then again, I have to explain what's a k-nearest neighbor. Okay, so yeah. Okay, I think this is a better sentence. Generalizes to new cases using a similarity measure. you use a similarity measure, and using that, we assign the label of the new instance, for example. Okay, that's instance-based learning. Doesn't have a uh, it's like doesn't have a model in itself. It's some sort of learning by heart. Okay, all right. Okay, so we are at the end of the main part. These are some important stuff. It's philosophy, and I just want you to go through this. Nothing fancy. If these are some kid stuff. What are some main challenges in machine learning? The most, okay, I won't use the word most. All of these challenges are equally important. But if I were to personally assign something uh, as the most major challenge in ML, I would rather say uh, maybe poor data quality. Okay, but that's all right. This could be one of the challenge. Insufficient quantity of training data. Okay, if the training data is more, you have more data to get insights from. All right, and that helps to make a better model. But if you have insufficient training data, then it's going to be difficult for you for machine ML algorithms to work. Okay, that's a major challenge. One more challenge is the non-representative training. So the problem is the training data, the data on which these models are trained needs to be representative of the kind of the problem we are solving. Okay. For example, if you want to decide whether the mail is spam or non-spam, you need to actually train the data on emails that are potentially spam and potentially non-spam. It needs to be representative of the kind of the problem we are solving. Otherwise, the model will learn something else. Okay, the next one is poor data quality, which is a pretty simple thing. The data you have needs to be of good quality. If the quality is not good, then you wouldn't have a proper good model. Then the fourth is irrelevant features. Simply explain, it's called garbage in, garbage out. If you put irrelevant information in the model, not irrelevant. If you put garbage in the model, if you train the model on garbage, then you would get garbage. That's what it means. If you train the model on irrelevant features, the model will not likely learn something you would like the model to learn. Okay. So this is a major challenge. We need to make sure that the features are relevant to the kind of the problem we're solving. Okay. So selecting feature engineering. Okay. So selecting, extracting, and creating good features. All right. Okay, so this is one more challenge, overfitting the training data. It's a challenge. So what is the overfitting? To explain very simply, you are asking a 12th standard student to solve a question from first standard. Okay, that's some sort of overfitting. It's overfitting. All right. The 12th standard student is overfitting the kind of the third standard problem. Okay. What is underfitting? The other way around. You're asking a third standard student to, for example, solve a 12th standard problem. That's underfitting. So overfitting is nothing but so what happens in overfitting is you perform very well on the training data, but when I give you new instances, you do not perform well because you overfit it. The model is too complex relative to the amount and noisiness of the data. It detects patterns in the noise itself. Okay. There are some solutions we will talk about in our forthcoming sessions, but this is overfitting. Underfitting means the same thing, the opposite of overfitting. The model is too simple to learn the underlying structure of the model is too simple. That's underfitting. Okay. The third grade student is too simple or too naive to solve a 12th grade problem. You're underfitting it. So there are some solutions. We will talk about the solutions, and in both of these cases, you'll see that this is a very interesting solution. And I will talk about this in our next slide. Regularization. We call it regularization. Okay. Maybe next slide. Not sure. Okay. Any questions so far? Do you guys have any questions? Sir, can you explain in Hindi? I'm saying this because Hindi is my mother tongue, so I'll be able to understand better in Hindi than in English. It's not that I don't know English, but I'm more comfortable in Hindi than English because I'll be able to understand things. Right? I see. I'm so sorry. I wish I could explain in Hindi. But the thing is, I'm not very proficient in Hindi. I mean, please feel free to ask me if you do not understand any questions. Don't shy away. What you can do is if you feel a bit shy to ask questions, there is this option in the Zoom where you can write only to me. And when you write only to me, I'll understand that you're asking only to me and I won't disclose your name. All right. So yeah, then you won't have to be shy, I guess. All right. So you can do that. But I really wish I could have explained in Hindi, but I mean, I can speak Hindi, but I mean, it would be difficult for me to explain the ML concepts in Hindi. So I hope that is not a problem. Yeah, I'm really, really sorry about that. I wish I could help. But you can ask me in Hindi before. Okay. Well, the next question is what are outliers and noise? Okay. How overfitting affects ML data? Okay. So let's try to answer the first question. What are outliers and noise? Uh, outlier is something. Okay. So let me look at the. Okay, let me look at the exact definition of outlier. Just give me a minute. Outlier meaning. Just give me a minute. No, these definitions are very general and they won't work pretty well. So I'll just probably okay. So imagine that you are trying to solve a problem, a machine learning problem, and you have this instance in your training data, which is very, very completely different from the kind of the problem you are solving. Okay, that could be an outlier. So an example of an outlier could be, for example, you are trying to make a model that tries to predict, for example, the height of a person or the weight of a person based on its height, say for example. Then in the training example, you find that, oh, there is this person who weighs like 10 kgs and he has a height of 6 feet. And that's very rare, right? You won't likely find such an example where the height is 6 feet, but he only weighs 10 kgs, right? But there it is in front of your eyes. You have this person. Maybe he looks very slim and he only has bones visible, on him, but that particular person exists. But he's not the kind of the person which represents the general kind of people you will see. Okay, so this particular person who is 6 feet and weighs 10 kgs is an outlier. Okay, if that makes sense. What's the next question? The next question says, okay, what's noise? Don't worry much about noise. Noise is something, some random fluctuations that occur in data that can be thought of as noise. Okay. Okay, great. I'm great you understood this. So kindly explain how overfitting affects machine learning data. Okay. So okay, so overfitting, say, let me explain this way. When I overfit the data, then okay, so something like this. So imagine that there is a class 3 student who goes and attends the 12th standard math classes. All right. Or maybe the opposite way around. Okay, this would not be a good example. So, okay, to briefly answer your question, when you overfit, you perform very well on the training data. But if I give you a new instance and ask the model to predict, you wouldn't perform well on that, because some sort of you have memorized some sort of information. Okay, and that memorization doesn't work on the new instance because it's not something you are trained on. It's completely new. That's how overfitting affects ML data, to answer your question. It performs very well on training, doesn't perform well on tests. Okay, we'll see some examples about this later on. Any more questions? Did you understand? UT Sharma, did you understand? Okay, yes, yes. This document will be provided to you. Don't worry. I'll send a link to you. So there is this question that says, okay, can we take the example of recent Indian voters data that shown by Rahul Gandhi? Is it the example of outliers? Oh yeah, yeah, could be. I am not aware of, but I'm aware of this Rahul Gandhi thing that happened. Let's not talk about politics here. But yeah, I mean, if okay, I'm not much aware of the context, but I do know that some sort of some stuff happened with this Rahul Gandhi and BJP votes and voters and something. Yeah, it could be thought of as outliers if he's right. I don't know about that too. The disturbances are noise. Yes, yes, the disturbances are noise. I mean, there are lots of synonyms you can use: disturbance, random fluctuations, random errors. Can we consider that we put up a filter out the data in LinkedIn to overqualified applicants? Can we consider that we put a filter out that in LinkedIn to overqualified applicants? Yes, yes, that's something you can do. Overfitting example. Yeah, yeah, you can. Yeah, overfitting is overqualified kind of stuff. Yeah, you can think about that. So, if I say you are over smart, you are likely over smart, but you wouldn't perform well in life. One example you can think of. It doesn't make sense, but you are overqualified. Maybe you are overqualified, but you need to make sure that overqualification doesn't affect your. Okay, the next question is, can we say noise is unwanted things in data set which can occur issue in future? Uh, noise is, see, noise is unwanted, okay, but you cannot get rid of it. Noise will always be there. So noise will most likely cause issue in the future, but you cannot remove the noise. The noise will always be there. There are always some errors. For example, if I ask you to measure the height of the room you are in, and you don't have if the height is if it's too tall, and you do not have a proper chair to do all sorts of measurements, you're gonna most likely make an estimate, and the estimate will have some sort of an error. Okay, that the error is going to be random, and that random error is some sort of a noise. You cannot escape it. The noise will always be there. All right. I hope I've answered your question. You cannot get rid of the noise. The noise will always be there. But yeah, the noise do cause issue. Uh, but that again, you need to know that you need to work with the noise. Okay. Sir, give example for semi-supervised. Oh, that's a good question. Thanks for asking that. Okay, let's see. Let's give an example of a semi-supervised learning. Have I not given here? I should have, right? The Google Photos thing. Let me check. I mean, I have given, though I haven't explained it. All right. How do I explain semi-supervised learning? Let's see. Um, right. Say, for example, okay, just give me 1 minute. Let me think. Most probably I'll take the photos example, but I think I have an example with me, but I just have to check where have I put that example, because I need to make sure that the example I use is something that you all understand well enough, makes you right. Where have I put that example? I put it here. I think I have. All right. Let's see. Okay, I cannot find the example, so I'll just try to explain myself. So, right. Can you explain the term regularization? Yeah, I will explain. Don't worry. I will explain it in the next slide. But let me give you an example of, let me give you an example of semi-supervised learning. So when I say semi-supervised learning, I mean that you have only a few data points, and you'd like to use that uh, to predict the next sort of new instance. Okay, so let's take this example. Suppose you'd like to classify 1,000 emails as spam or not spam. Okay. And you only have 10 emails which has been classified for you by a teacher as spam or not spam. So you have 10 emails as such. So the first email is a spam, second is a spam, the third is not a spam, the fourth is a spam, and so on and so forth. Now, why is a semi-supervised learning problem here? The reason it's a semi-supervised learning problem because you only have 10 emails, which is very, very small. And you using only these 10 emails, you will have to classify 1,000 other emails as spam or not. The case would have been different if you had 900 emails which are classified for you as spam and not, and you use these 900 emails as your training data to classify the rest 100 emails of the 1000 emails as spam or not spam. And now you only have 10 emails which are classified for you as spam and not spam. And you need to use this information to classify the rest 990 emails as spam or not spam. So how do you do this? Simple. So this is a semi-supervised learning problem. So what you do is you train a model. You train a model, say for example, any model on this 10 data. All right. You have a model M, say for example. The name of the model is M. And the model M is used is trained on only these 10 samples. Now using this M model, you classify 10 other emails using this model M. You classify 10 other emails as spam or not spam. You use this model. Okay? You do not use a human. Okay? If you use a human, it's going to be supervised. You use this model M to classify 10 other emails as spam or not. Now, how do you decide which 10 emails you will use to classify whether it's a spam or not? The idea is pretty simple. The emails which you are very much confident about as spam or not spam, you classify those 10 emails as spam or not spam. Now you have 20 emails which you have classified as spam and not spam. And repeat the process over and over. In the end, you will have all the 1000 emails classified as spam or not spam. That they won't be very accurate, but at the same time, you do not have that with you. This is the only way you can go through. Did I answer your question? Did you get my answer? Did you get my Shiva Shankar? I hope you got the answer. Did I answer your question? Okay, great. So, sir, can you explain the term regularization? Oh, I mean, don't worry about it. Regularization is not something I would like to explain right now. Just take it for granted. Regularization is something which has a mathematical flavor to it. So I'd rather keep it. Okay. Okay, there are no questions. Let me finish it off. I don't have much time. So how do you train a model? So this is an example of how you train a model. Okay. So you have a training set. You have a training set. You train the model on the training set. Okay. And you test the model on a test set. Okay. So the training set is the set where you train the model. And the test set is the set where you use the model to test it. Okay. So you split your data into two sets. Okay, there is a question. I won't reveal the name because the particular person is most probably shy. Sir, can you give some examples of spam email detection models? You can pick any classification problem. It's a classification problem. Just have to look, for example, uh, a classification model. Okay, so one good example that works pretty well here is let me think which model works pretty well with spam classification. I think it is no, I mean this is the information we need to check which model usually works pretty well with spam. There are lots of models, but some models works pretty well. I'm not sure which one. Let me check. Works pretty well in spam classification. Okay, so there is this algorithm called random forest classification. So you can use random forest classification. I think it works pretty well. This is all I get. This is what I got. So maybe we'll talk about random forests tomorrow. It's a very powerful ML model, and it's a bit difficult to understand if you're learning it for the first time. Uh, but yeah, okay, there is one more question. Which is more better, to pick up a model for your project or create a model? I think to create a model is better because your model, the model that you are going to use, is going to be dependent on the kind of the data you're using. So I'll most likely go ahead creating a model on the data you are working with. If somebody else has worked with the same data that you are working with, then you can pick up the model that particular person found out to be as the best. That works well as well. But it's highly unlikely that if you're doing a research project or some sort of a research work, then most probably you would be working with, for example, most probably you'd be working with data which is not very known, not very not very visible in the internet. So in such a case, most probably I would go ahead creating a model on my data and then run my model on it and see which one performs well. I hope I have answered your question. Okay, there are no more questions. I think I can go back to the last part. Usually we import models in your project, like so these are models. You need to train these models on your data. Okay. Yeah, okay. Yeah, you need to train your model on your data. So I don't know what you mean by that, but I mean I'm assuming that though the model is the same, the type of the model is the same, but the model is going to be different. Uh, you need to tune your model on the data you're using. The parameters or the weight, for example, is going to change based on your data. But yeah, the type of the model uh, is most likely going to be the same across entire domain of such kind of problems. Okay, great. So I am on the last few slides. So you split your data on the training set and you split the data on test set. So you train your model on the test set, you test your model on the test set, then you have a model. And then you deploy your model. You put out the model in the public and let people test it themselves. Okay? That's the usual protocol. Your goal is simple. You only have the privilege to use the training set. How you use the training set is completely up to you. The goal is you need to train your model on the training set in such a way that you have the least generalization error on the test set. That's the main protocol. That's the main motive. Okay. I'm repeating again because it's very important. You need to train your model on the training set such a way that on the test set you have the least error. Again, uh, having a having the least error in the test set doesn't guarantee that the model is going to perform very well, because maybe your model is overfitting. How do you know that? Okay, in such cases we use these regularization things, which we'll talk about after some time. But my point is simple. Although the goal is to minimize the error in the test set, it should minimize the error and test it in such a way the model usually performs well outside your environment. All right. All right. So, okay, there is a question. Is there a question? Okay, there is a question. So someone is asking, how can we choose data split into training and test set? So I'm sorry, I did not get your question. What do you mean by how can we choose data split into training and test set? I mean, please feel free to go ahead and update your question or rewrite the question again. I would be happy to answer it. Okay, in the meantime, let me continue. Okay, so this is splitting your data. You split the data on training set and test set. You train the model on the training set. You check the performance of the model on the test set. If the test set performance is good, you deploy it and make sure that at the same time, you need to make sure that the data is not overfitting, stuff like that. Okay, the hyperparameter tuning problem. So don't get afraid with these words. Hyperparameter, parameter tuning. They are not very seem like some grandiose adjectives they're using or some fancy words, but it's a simple thing. What's a hyperparameter? What's a parameter? What's a hyperparameter? So parameter are the variables or the entities in your model which is learned, not learned is, how to explain. Sorry, let me drink some water. In the meantime, if you have any questions, or maybe did you update the question? Okay, there are no questions. So parameters get updated. Again, I'm having a bit difficult explaining because they generally use some gradient descent based things, and I don't want to use these words right now. So parameters get updated. They are learned. Okay. Hyperparameters need to see which one works, which one. Okay. So if you measure generalization error multiple times on the test set to find the best model hyperparameters, your model will be tuned for that specific test set and may not perform well on new data. Do you see the problem? Do you guys see the problem? I'll give a minute. Oh, don't worry, we'll finish on time. I'll just give a minute to take a pause and make sure you understand the question. Okay, so the updated question is, let me read it. What criteria determine whether data belongs to the training set or the test set? Oh, that's a good question. That's a good question. Let me answer that question. Just give me 20 seconds so that I can frame the best way I can answer that question. What criteria determine whether data belongs to the training set or the test set? Okay. So let me answer this question this way. The training set and the test set, right? The test set should be representative of the real world. Okay, that's what I mean. That's what I would like to say. So you wouldn't want to test your model on a set which is, say, for example, is not representative of the world which the model is going to work in the future, is going to get deployed. Okay. So if you want, so imagine the Gmail is your model. You wouldn't want your test set to have too many, for example, okay, you wouldn't want your test set to have emails of one particular type, right? Because Gmail, the application Gmail has to deal with, doesn't deal with emails of only one particular type. It deals with emails of all sorts of types, right? So you want your test set to represent that kind of information. To answer your question briefly, this is what your test set should look like. It should look like most probably the real world scenario. Okay, that's what. And again, on the realm of training set and test set, there are different ways you can create training set and test set depending on the type, depending on the data you have. You can simply randomly pick 60% of your data as training and 40% as test. We can randomly pick 80% of your data as training and 20% as test. So there is this in scikit-learn, there is this thing called train test split. Again, you need to decide whether it's whether you want to do it 60-40 or 80-20 or 90-10 or 50-50. It's upon your choice, but people usually go for 80-20. Some people go to the extent of 60-40, but it's rare to see people going for 90-10. Yeah, 80-20 is quite common. 80% of the entire data is training and 20% of your entire data is test. So these are some some ways you can determine, you can use. Okay, more questions. How do you choose which algorithm to use for a specific problem? Oh, that's a good question. Thanks for asking. How do you choose? So, um, right. So again, your choice would be based on the kind of the problem you're solving. If you would like, if you are solving classification problems, you're most probably going to look for classification-based algorithms. If you're solving a regression problem, you will most likely go for regression-based problems, right? Regression-based models. If you're solving a problem, an online learning problem, then you're most probably go for online algorithms. There are different online algorithms. So there is one called, what do we call it? Uh, Stochastic gradient descent. So this is again a gradient descent methods, but there is a stochastic gradient descent based online learning things you can do. So this is one way you can choose your algorithms. Again, on the realm of all the classification based models that you are using to solve a classification problem, you would most likely try out all the models and see which one performs well. It's not a very easy question to answer. Among all the classification based models, which one performs well? You would most probably have to try uh, almost all of the classification based models to figure out which kind of the model works best. I hope I've answered your question. Shailja, okay. Sandesh, okay. Sandesh is asking, how do you choose which algorithm to use for a specific problem? Okay, right. Oh, you have already asked this question here. Okay. Okay, no more questions. Okay, there is one more question. Oh, that's fine. That's fine. No worries. No worries, Shailja. That's fine. Uh, okay, right. So this is a hyperparameter tuning problem, and there is this thing called validation set. What you do is there is this technique called cross validation. So what you do is you have the entire trading set. You have the entire data. Right? Yes, Shailja, please go ahead and ask your question. And can anyone just help her unmute? Sorry. Okay.
So actually, I was the host of the meeting and I was disconnected. So I request you to please make me the host so that I can let people in and manage the meeting.
Okay. I have met you a co-host, right? I think I have met you a co-host. Wait.
Okay.
Okay, I have made you a host. I am a
Okay, sir.
co-host.
Thank you.
Okay, yeah,
Okay.
sure. Yeah. Right. So we are almost done.
And sir,
Yeah, sorry, go ahead.
please end the meeting soon because we will resume the meeting on 5 p.m. again. Because the students have to take a break for the lunch and all.
Right, yeah. I have finished it almost. So I just like to say one thing.
And sir, before completion, so please change some slides and we will record that for the reference of this meeting. So I would like to ask all the participants to on their cameras for the last few minutes.
All right, sure, no worries. Yeah, I'm almost done. I just like to say this cross-validation thing. It's simple. It's what you do is you have the entire data set. You divide the data set into 10 parts, okay? And you train the model on the first 9, you test on the last 10, okay? And then you train, this is one way. The other way is you train the model on the 9, a different 9 set of parts, and you test it on the other 10 set. So you can do this 10 times. So using this 10 times, you can make some predictions. So this is called cross validation. Maybe you can have a look at this. Yeah, this is all I have. I've finished it. Summary is pretty simple. ML is about enabling machines to learn from data. Systems can be supervised, unsupervised, batch, online, instance, model-based. A typical project involves gathering data, feeding it to a learning algorithm, and tuning a model to make predictions. Success depends on having enough high quality, representative, and a good set of features. The model must find a balance between being too simple, which we call underfitting, and too complex, overfitting. Remember, both of them are issues. Underfitting and overfitting, both of them are issues. All right, we need to find a balance between them. And the last one is always evaluate your model's ability to generalize using a holdout test set, right? Which is we call it cross-validation or something. This is all I have. And yeah, thank you so much for attending. We will see next. If there are any questions. All right, we don't have any more questions. This is all I have. Thank you so much for attending. And yeah, I would like to give my mic to Shelja. Shelja, can you hear me?
Yes, sir. Thank you everyone for the meeting for joining the session. Now we'll end the session and we will continue this on at 5 p.m. again. So
Okay.
kindly join on time.
And do you want? Okay, so people. Right.
And
One second.
uh, we'll connect on 5 p.m.
Okay, sure. We can connect on 5 p.m. Sure. Thank you.
Yeah, everyone can now leave the session. We will rejoin the session at 5 p.m. with the same link. Yeah, thank you everyone, and we will meet again at 5 p.m.